Hello everyone. In continuation with the Fourier series, we'll be going ahead with the even and odd function, and this is the part 4. So the question is, find the Fourier series of the function f of x is given as f of x as 1 plus 2x upon pi in the interval minus pi to 0 and 1 minus 2x upon pi in the interval 0 to pi, and hence deduce this particular series. So let me just make it again two parts. First is this where we are to find out the Fourier series, and the second one is this where we have to show that the series of in the form. Okay, now if you observe this particular function, this type of function of even and odd function we did not deal with. So there is a little bit of different approach because of this intervals has been divided into two parts or piecewise function. So let me just go ahead with this. F of minus x is equals to, again this has been given to you as minus pi to pi, and therefore we can go ahead with even and odd function. So if I'm replacing every x by minus of x, so this entire function I could write down as 1 plus 2 into minus of x upon pi. So this will also change because every x I'm replacing. So intervals are also getting replaced as minus of x. So what will happen here? So f of minus x would give me 1 plus 2 into minus of x upon pi. This interval becomes minus of pi less than equals to minus pi less than equals to 0. So this is what is happening in the first case. But this first case as in this is same as equals to 1 minus 2 times x upon pi. That means I'm just solving this previous step. Do not get confused between this step and this one. But we are getting the same step, same interval from the minus of x. So it's 1 plus 2 times minus of, so minus x will come here. So 1 minus 2x upon pi. And this minus of pi is less than equals to minus x is less than equals to 0. So if I'm multiplying this entire interval, by minus of 1, because I don't want the limit in minus of x, I want the limit in x, and therefore if I'm multiplying this, so what will happen? It will been given to me as pi, but this less than equals to sign will become as greater than, so it will become as pi greater than equals to x greater than equals to 0, right? And this is what is been we can write down in this way. So this pi greater than equals to x greater than equals to 0 can be written as 0 less than equals to x less than equals to pi. And that is what, if you'll observe the second, whatever we have got it from the by putting the minus x here, we have got the second step or second interval what they have defined here. That is 1 minus 2x upon pi in the interval 0 less than equals to less than equals to pi. That means what, after putting f of x, every x by minus x, I'm going to get as f of x, and therefore I could write down as f of minus of x as this, and therefore we are going to get the same. So what we have done, we have just put f of minus x in the first case, first piecewise function here. We have got the second. Then here what we have got, what we have done it here in this particular thing, we have put it here in the second, and we have got the first. So ultimately, actually this is a minus sign here, I forgot to put it. So this is what we have got it from the both the steps. So that means what, we have both the cases we are getting the same function, and therefore we could write down as f of minus x as f of x. So this is the way, in this way you need to deal with the even and odd function whenever the function is been given to you as a piecewise. Rest of the entire procedure will remain the same. So this is what you need to check it up or need to note it down, that how to deal or how to check whether the function are even or odd when the functions are given in the different intervals or when the functions are given in the piecewise intervals. Okay, so therefore this is an even function. So if it is an even function, then bn equals to 0. Please do refer the previous sessions wherein I have explained you from where this is, what will happen if the even functions, and what are the coefficients are going to be 0 when the functions are even, when the functions are odd. So this is again, if you observe the interval is minus pi to pi, if the interval is minus pi to pi, then the L equals to pi we are going to get. If L is equals to pi, the function or the series is f of x is equals to a0 plus summation of an cos of nx, n is moving from 1 to infinity, and therefore we need to go for a0. a0 is 1 by pi integration 0 to pi f of x dx. Please do refer, I am continuously asking you to refer the previous sessions, otherwise this will be the difficult part for you all to understand this directly visiting to this particular session. So it's 1 by pi 0 to pi 1 minus 2x upon pi dx, and this is what we have done. So whenever I'm taking the 0 to pi, I need to take the value of the function from this particular interval, that is 1 minus 2x upon pi. So throughout, whenever we are dealing with the interval as 0 to pi, we have to take the function value as 1 minus 2x upon pi. As the function is even, that means the function is symmetric to the y-axis, and therefore we could take either the negative part or either the positive part. The function remains the same. And if you'll observe that we have taken it here 2 times, and therefore this will not affect it any time anymore. So it's 0 to pi 1 minus 2x upon pi dx. The integration would give me x minus 2 by pi x square by 2, 0 to pi, and after putting the limits over here, I'm going to get it as 0, because here it is pi minus pi square by pi, so this will give me pi, so pi minus pi will give me 0. So this is what we have got, a0 as 0. So we have to go for an is 2 by pi 0 to pi f of x cos of nx dx. We have got f of x as 1 minus 2x upon pi, integration is 0 to pi. So again we have to deal with the first and the second function as it is. So this is first and second function using LIATE rule, and we have seen that those many questions so many times. So first function as it is into integration of the second would give me sin x nx upon n. So now this is not a first function, no, not a second function so far. This becomes the first, this becomes the second, minus the first function differentiation here, that is minus of 2 by pi, and integration of the second function would give me minus of cos of nx upon n square. So now this is not the first function so far, this becomes the first, this is not second, this becomes the second function. Next step would be plus, because it is a plus, minus, plus. Next step is the first function differentiation would give me 0, and therefore the rest of everything would go to 0, and the limit is from 0 to pi. Now the limit is from 0 to pi, we need to check it up. We need to check it up with this sin of nx. This term would go to 0 for x is equals to pi and for x is equals to 0. So therefore this term we need not to consider, we have to just consider about this second and into 0 to pi. So that is what has been done it here. Just a simple simplification, and this is the reason I could give you here, that is sin of nx will go to 0 at x equals to pi and x equals to 0, and therefore we have to just consider the second term to go ahead, and that is what we have done it here. So every x been replaced as pi minus every x been replaced as 0 would give me minus 2 upon a pi n square cos of n pi plus 2 upon pi n square, which is equals to 4 upon n square pi square, and it is 1 minus cos of n pi, and we know that cos of n pi is minus 1, actually it says minus 1 to the power n here, and therefore 4 upon n square pi square into 1 minus 1 to the power n is the answer for an. So this is the answer for an. Now we have got a0, we have got an, so we have to just write down the series here. The Fourier series would give me f of x is a0, we have got 0, plus 4 upon pi square is a constant, summation of 1 upon n square 1 minus 1 to the power n cos of nx, n is moving from 1 to infinity. This is what we have got it as the Fourier series, but we have to deal with the particular series as well, so we are just have to simplify this further. That simplification would give me 4 upon pi square summation. So this is what we have done. Now whenever I am getting n equals to 1, n equals to 2, n equals to 3 and so on, now just look at this factor in the numerator, wherein I have got it here 1 minus 1 to the power n. So this 1 minus 1 to the power n, when my n is equals to 1, what will happen? N equals to 1, this minus 1 to the power 1 will give me minus 1. So 1 minus 1 will give me 2, and therefore I am getting n equals to 2, n equals to 1. What will happen? This factor would going to give me 2. What will happen if n equals to 2? If n equals to 2, this minus 1 to the power 2 will give me plus 1. So 1 minus 1 will give me 0, right? So n equals to 2, n equals to 3, what will happen? Again, this minus 1 to the power 3 would give me minus 1, minus becomes 2, minus becomes plus, and therefore 1 plus 1 will give me 2. When n equals to 4, then it will give me again 0, as minus 1 to the power 4 will give me plus 1. 1 minus 1 would give me 0 here. and therefore this values will give me this 2 when the values are odd values, that is 1 1 3 5 7 and so on, and when this is equals to 0 when the values are even of this n, and therefore these are the values when n equals to 1, n equals to 3, n equals to 5 and so on. The rest of n equals to 2 4 6 everything will go to 0. So this is what the simplified version of this function would look like. Now there is one another second part is that is we have to show that this series. So we have to observe that we need at 1 upon 1 square, 1 upon 3 square, 1 upon 5 square, and we need at pi square by 8. So if we'll put x is equals to 0 in this particular series, because why we wanted to put x is equals to 0, because we don't want this cos terms here, and even we don't want any alternate plus minus sign. So that is the reason we want this cos of x, cos of 3x, cos of 5x, everything should be equals to 0. So after putting x equals to 0, I'm going to get the series something like this, which is f of 0 is equals to 8 upon pi square, 1 upon 1 square cos of 0, cos of 0, cos, and we know that cos of 0 is always equals to 1, and therefore this entire thing will move to 1, move to 1, move to 1 over here, and rest of the things are, this is the terms which we require. But as we have a function as a piecewise function f of 0, we need to go ahead with the limit function, because we need to go for the left hand side limit, right hand side limit of this function, because we have been given this function as a piecewise continuous function. So it's 1 by 2 limit from the left hand side of f of x, from the right hand side of the f of x. Now what will happen, that means what, in the function that 1 plus 2x upon pi and 1 minus 2x upon pi, we have to put x is equals to 0. Both the cases we are going to get the value as 1 of this function at the left hand side and the right hand side. So we are going to get f of 0 is equals to 1, and therefore this f of 0 is equals to 1, and we are going to get our required series or the answer for the second question what we have seen in the first page. So this is what has been the asked, and we have seen that how to treat with the piecewise function, how to treat that function to show that even an odd function. I hope you must have understood this particular question, where the question is been given to you as a piecewise. Okay, and this is the self-observation slide wherein you have been given 2 questions along with the 2 answers, so you can go ahead with the solve the questions, and if at all you have any query, please let me know in the comment section so that I could address this one. Yeah, thank you. Happy learning.